Okay, for this next problem, we've got two different classes that are taking the same test. Apparently, they are very small classes. Mostly this is because I didn't want to do a lot of work. So the teacher wants to compare the results between both classes. So most of the time, teachers probably use the mean. So you can calculate the mean. I already did this, but you add them all up and you divide by 5. And the mean of this is 84.2. So this class average, we might say, is 84.2. Second period, if you do the same thing, add up those 5 numbers, divide by 5, their mean is also 84.2. So, what do we notice? Well, they have the same average values. Now, does that mean that the two classes did the same on the test? Well, let's look at this. First period, we've got a B, a C, this is an A minus, a B plus, and a C plus. Okay, so we've got between C's and a low A. Second period, we've got a C, a B, an A plus, and a D plus. So second period's test scores are a little bit more spread out. Okay, so even though they have the same mean, the data sets are going to be very different. So a lot of times when this happens, we need something else to describe the data. A lot of times, the mean isn't enough to tell us. It tells us where the center is, but it's also helpful to know, well, how spread out are the data. So that's where our next value comes in, which you may not have dealt with before. It's called the standard deviation. Okay, so it's a measure of spread or variation. There are other measures of spread and variation that when you take a statistics course you will learn about, but the most common one is the standard deviation. What the standard deviation describes is you take each value and say this is how much each data point, this is how far each data point is away from the mean. Okay, so it tells you how spread out they are. So this is how you calculate. This is the formula, okay? This is a Greek symbol, sigma, it's a lowercase Greek letter. And it's the square root. Now x1, this x1, x2, x3, x4, all of those are like the test scores. Those are the values. And then this is another Greek letter right here. It's called mu. Mu is the mean. Okay, so you take your first test score, you subtract the mean, and whatever you get, you square it. And take your next test score, you subtract the mean, you square it. And you keep doing that for every single data point. You divide the whole thing by the number of data points you have and take the square root of it. So we're going to actually do this. And this is kind of an obnoxious thing to calculate, which is why I only had 5 kids in my class. So you can thank me for that later. So first, let's do first period. Okay, remember the mean on both of these was 84.2. Okay, so for first period, we're going to take each of these scores. We're going to take 85 minus our average, 84.2, and we're going to square that. So we did that one. Now we're going to take the next one, plus the next one, 76. 76 minus the mean and square it. The next one, 92 minus the mean and square it. The next one, 88 minus the mean and square it. And the last one, 80 minus the mean and square it. Okay? So put that all in your calculator. Okay? You just put it in with the parentheses exactly how it appears, and you get, I already did this, 160.8. Now, in the formula, then you have to divide by n. N is the number of test scores, so there's 5 of them. And then we're going to take the square root of that. Okay, so when we take 160.8 divided by 5, take the square root of it, you end up with 5.67. Okay, so what this is telling you is our mean is 84.2. Okay, that's our average. And then on average, our data points are about 5.67 away from that. Now, what's really helpful is when you find 2 different standard deviations, and then you can compare them. So we're going to do the same thing for second period. We're going to calculate the standard deviation for second period. So we're going to do the same thing. Take our first test score, 75, minus the mean, 84.2, and square it. Next test score, 85 minus the mean, square it. Next test score, 95 minus the mean, square it. Next test score, 98 minus the mean, square it. And last test score, 68 minus the mean, square it. Okay, put that all in your calculator with the parentheses. Okay, exactly how it appears. And I already did this. I got 654.8. You have to divide by n. N is the number of test scores. Divide it by 5. Take the square root of the whole thing. When you do that, you get 11.44. Now, here's what we can look at. Both of these classes had the same mean. First period, their average spread was 5.67. Second period, the spread is 11.44. Second period has a much larger spread in their data. So even though their average is the same, even though the mean is the same, second period is more spread out. And that's what the standard deviation tells us. Again, standard deviation is a little obnoxious to calculate, so when you have large data sets, later on I will teach you how to use a spreadsheet to calculate this, because I'm not going to ask you to do this for things that are much larger than this because it's obnoxious, but it does give you a really good idea of what you're doing.